This is the part I just talked over the intro, like one of those cool announcer guys. Howdy everyone. Kevin, I see you at your first. Steven, posted me in the back room. What are you doing in the chat room? We're about to start it here in another minute. Thank you for hanging out. A quick shout out to all my Patreons who make the show possible. You can support me by joining Patreon in the link below. And on to Tank Radio!
Ladies and gentlemen, Frank!
Mic. Welcome to Tank Radio. We'll try that one more time with the mic active. I'm Frank, KG5HJ, and what's going on out there, all my takers out there? Man, oh man, what a weekend we had. Yeah, I fixed the mute. It's coming. You got another 40 seconds. I can also, there we go. I think everything's working now. It's the little streamy things, man. I'm getting used to it. I'm getting there. I need to calm down. I don't have Sean on today. He usually slows me down a little bit, so I'm trying to do that. Special things coming up, though. In the Grapevine Amateur Radio, we have coins for sale. My Tank Radio coins are on pre-order. They're getting pretty close and getting shipped. I just need one more thing to have before I can start shipping them. I am so close. It's a printer, but I'm so close. I need to start printing the labels. And once I'm there, I can get them to ship. So I'm maybe another week or so. But while you're there, there's also t-shirts. If you buy a coin with some other merchandise, it might get out today, but I'm not quite sure. Jason's about to go on a nice little trip down to his other house. Man, I wish I had that other, 100,000 subscribers money so I could get another house. What is up? I see everyone out there. Howdy, howdy, howdy. What else do I have going on? I also have this awesome, it's down here, buy me a beer link. This link helps to promote the show. Every dollar goes right back into the show. And I had one person that bought me a beer through since the last stream. I'm pulling it up now. You think I'll be a good YouTuber and have it up already? Um, it was Skeeter 1 week ago. Thank you, Skeeter, for buying me a beer. And also, someone named someone. Thank you for buying me a beer. I really do appreciate it. And it's Alexand. Thank you very much, Alexand. I know who you are. And that's about it. I'm gonna go ahead and pull in our guest today. Coming up. I gotta find the right scene. I'm almost there. Here we go. Oh. We get a little inception going on. Oh. Sterling, man. Welcome. There we go. What? Oh, you're outdoing me. I did that one year for a Christmas, or it was a New Year's stream we did. It was a happy hour. I was outside smoking a cigar. It was awesome. You're But you're outside at 62. Jeez. I am. Mhm. But you're outside in short sleeves. I can't do that anymore. Zoom is muted.
Just wait
There
for
we
the
go.
summer.
Yep. Welcome. I muted you. I'm sorry.
Glad to
You're
be
now
here.
live.
Oh, that's terrible.
I
All right.
know.
Anyway, coming
You.
to you live from St. Louis, where it's 62 degrees, and I have a fire.
Look at that fire. Oh.
Ugh.
If I knew
Oh,
you were
don't
doing
fall
that,
in.
I was
Whoop.
set up outside. No, don't fall in. Don't fall in, man.
Hopefully
Oh,
my mic is working. I just
y-
decided at the last second to go out here to the back porch because it's just so nice.
oh man. It's 62
And I'm trying to
degrees.
figure out how
Nice.
to like link my iPad. Yeah, it is. It's 62 degrees in St. Louis,
Mm-hmm.
Missouri, where I'm hailing from, and we're just cherishing it because next week it's gonna drop 7 more inches, 8 more
Mm-hmm.
inches of snow, and be 3
Ooh.
degrees.
No, I'm
So
done.
don't want that.
Tank radio
Yep.
out. We're over. But I have something for Jason's stream. Last of my Knob Creek. I'll be drinking tonight.
Mm.
But today's topic is feedlines and lightning arresters. And I was talking to you a little about this. I am gearing up to start my shack, and you see things on the ground over here, the wires and boxes. This weekend, I moved the picture frame, so the tilted fixture is back. You can go ahead and keep commenting. Maybe one day I'll straighten it, even though I just put it up on that wall, but we're not going to talk about it. I had a guest on in a previous stream talking about grounding and what he recommends for grounding. So now I'm trying to learn about feed lines and lightning arresters. And should I have a
That's why I'm
lightning
here.
arrestor? What kind of feed line do we need? So help me out with this. I'm kind of complexed on what do I need to do. There's so many options. Where do you want to start?
Well, there are two very, very different topics. So
Mm-hmm.
feed lines are the thing, the cable, the wire that brings your RF from your radio to your antenna.
Mm-hmm.
And then lightning arresters are what go in that line to prevent transient electromagnetic surges from damaging your radio equipment. So it's actually a good topic because they kind of go hand in hand.
Mm-hmm.
And I mean, but there's the whole grounding and bonding thing. I don't think we'll dive that deep, maybe a little bit, but like we'll talk about lightning rods, how lightning works, what you can do to prevent lightning strikes in the first place, which is you can, believe it or well, I guess you can, but you can make it go somewhere and not the other place. But
Yes.
we'll get to that. And how to protect your stuff that
that's
isn't
the
just
point.
unplugged during lightning storm.
Yeah.
So
Well,
right.
as a standard precaution, a lot of my big computer and entertainment system setups, I have the power cord strategically placed where I can, in a lightning storm, just grab everything and unplug the two hooks, and everything is gone.
Yep.
I only
Mhm.
done that a couple of times, but they're just so useful to have that. I do not want to just hit the off button because I used to work at a little repair shop a long time ago, and you know how often people brought in computers? I just flip the power off button and my computer don't boot anymore. And we open it up and it's just charcoal blackness everywhere.
Oof.
Oh, thank you, ma'am. Thank you, Tony. I really do appreciate it. I'm sorry, Tommy. Thank you, Tommy. I appreciate T-Ray, man. Woo! Thank you. Thank you. Dropped me 20 beers. Awesome. Thank you very much. I need to rename that
Damn.
to the Whiskey Supply.
Oh my gosh. Also,
Hey.
shout out to my lovely wife who just
Oh,
brought me a beer
thank you. We appreciate it. So in that
and
case,
sparkling water.
nice. Thunk. I'll go open up my whiskey. I might have to find another bottle for Jason's stream. He might kick me off. Ha! So, back to lightning. So,
Oh yeah, the thing that comes from the sky.
uh-huh.
I'm trying to figure out. I wish in the world, like, I have a iPad and I want to draw on it, but I don't know how to make this go to my Mac.
Mm,
It's magic, but I want um. And sorry for the like emergency services in the
it'll be gone
background.
in a
I live in
minute.
the city. Let's just take a minute to thank our ambulance drivers. I think that was an ambulance. Okay, they're
First
gone.
responders, thank you. We do appreciate
Yep,
every first responder out there helping us.
right on. So, like, actually, I really like. I saw this video a while last week, I think,
Hmm.
and it was a rocket launch, but it was into a cloud. It was a cloudy day. It looked like it was actually raining, but they launched a rocket, and it was from way far back, and the rocket was going real slow up, and then like it just got struck by lightning, and so from the heavens you can see like a normal lightning path, and then it hits the rocket, and it goes in a straight line past straight down to where it launched from. And I was like, holy cow, this is crazy. Like, because they launched a rocket and it must have followed like the smoke trail, but
Hmm.
actually they did that on purpose. What they were doing was identifying and analyzing like the lightning strike in the atmosphere using a whole variety of like instrumentation across like a field,
Hmm.
a very big like cow pasture essentially. And they actually do this in New Mexico. So I used to work at this place, the Very Large Array.
Ooh.
And just a couple miles outside of the Very Large Array in New Mexico is the Magdalena Lightning Research. That was the Langmuir, Langmuir Lightning Research Facility, and I think it's defunct now. But they used to do exactly that. It was the top of a mountain,
Hmm.
and lightning would. There would just always be lightning in New Mexico. Like you'd get these little pop-up storms, and if you were in the right place at the right time, you'd just get like crazy. And so they would launch rockets, like model rockets, with copper wire attached to the rocket on a big long spool up about like 400 feet. Lightning would just find it and chew it up, but it would give them a perfect like time and place to like point all of their sensors up to the top of this mountain so that they could get a 3D picture like in real time, like slow it down by a bajillion times to see how the lightning travels, what the shape is, what the width is, the voltages, everything, the current. It's like so cool. So it's a real thing, and it teaches us exactly what we're trying to figure out today: is how to prevent lightning damage from your radio system. So
Is that
hopefully that was a nice segue.
is that the place Mythbusters went and they did that lightning segment where they are hitting things with lightning?
Maybe
Maybe.
it very likely could have been. There's a few places like this, and they're in California, so there might be. Actually, they might have gone either to Colorado or New Mexico, but it's like there's a little bunker, and I have to remember it. I have to go back and watch it because I hardly remember it. But the entire surface of the mountain,
Hmm.
like about, I don't know, I'd say like a football field's worth of mesh, like steel mesh, so that they'd have this big ground plane, and then beneath that they had their little, lightning bunker where they could go hide whenever they launched the rocket and hit the button and all that stuff. So.
Hmm.
Um, Probably, but I don't know. No,
That's
I
pretty
barely
cool.
remembered
I
that
seen.
episode. There's so many.
Yes, I know, and I seen another TV show talk about that where they were doing the same thing. They had a rocket go up and seeding the lightning, and
Hmm.
like you said, measuring it. So what?
Exactly.
How can we take all that and put it into ham or radio and make sure the lightning doesn't travel into our shack? Because that's what I want to do.
So what we know about lightning is that it's a lot of energy and a lot of current and a lot of voltage, and it like any other electric current or voltage or power or any electric path,
Mm-hmm.
they Mr. Lightning, we'll call it Mr. Lightning, desires to flow in the path of least resistance.
Mm-hmm.
Okay, so that should tell you a lot about like how you're going to set up your shack and to make it so that your radio is not in the path of least resistance. And that is, as we all know, like unplugging the radio from everything, so including the power, the DC power and the outlet, and completely isolating the radio from everything, like unplug it from the computer, even the ground, because who knows if your ground is actually correct.
Mm-hmm.
Trust me, I know. Like I've had a ground like be a problem in a ham shack, and completely isolate the radio, because then if lightning strikes, your radio is totally untouched. Your radio is very far from the path of least resistance unless you put your radio too close, or your radio just is decided by Mr. Lightning that your radio is the path, but that's like
Mm-hmm.
very unlikely.
Mm-hmm.
So what can we do to avoid like local lightning strikes, not direct strikes, because direct strikes are very damaging. Like there is very little you can do other than lightning rod systems. So like where you have a lightning rod and you have all of the huge copper or aluminum like wire going from your roof down to your ground, where there's a big system of ground cables and wires, not just like one little measly lightning rod going into your 8-foot ground rod. That's not enough. You got to do like the whole perimeter, right?
Mm-hmm.
There is that, but most of us don't have that unless we live in Florida, or some places, in the South where lightning is just like super common. But in places like California, like LA, you'll get lightning every so often, like maybe once a year. Or places like, I don't know, Missouri or Texas, where you get storms pretty frequently, but like lightning doesn't really strike your house every day, does it?
No, but
But
there's
you still need
a
to
lot
protect
of
yourself.
close lightning strikes throughout the whole Dallas Fort
Yeah.
Worth. Come on, we are in Tornado
Yeah.
Alley. We know thunderstorms.
Oh, absolutely. And in fact, I had a local pet grooming shop just 400 feet that way
Mm-hmm.
get struck by lightning and caught fire. Small fire. They caught it and they brought in the fire department and they put it out. But like, you could just, the boom was just like, it was crazy. It was super close. We're like, dang. And for some reason, I was like, why? Like, there were just so many fire trucks and ambulances, and I was like, what's going on? So I walk out in the rain, and there they are, putting a hose to a fire, and they got it out, saved the pet grooming salon. But it just goes to show, even that lightning strike 400 feet away
Mm-hmm.
was enough energy to cause my like router, my
Mhm.
Unify Ubiquity like internet Ethernet switch to totally go on the fritz. Like I had to unplug it, reboot it, and almost to the point of like reflashing firmware before it operated normally again. Because that lightning is an electromagnetic pulse. It puts out a huge amount of energy in a massive field around it, because it is literally 5, 10, 20 miles long, coming from the sky, going to the ground, sinking bajillions of currents and bajillions of volts, amps and volts
Mhm,
into the
mhm.
ground. So that's what you really got to be concerned of, because you don't really get lightning strikes all that often, but you do very frequently get lightning strikes within 500, 1,000, 2,000 feet, which are still damaging and can cause problems, especially because your antenna is a big old piece of wire, and its sole purpose in life is to pick up those super, super weak signals. But if it picks up that super strong lightning burst really close, that could fry your diodes, fry your front ends, and do things that don't really look like black smoke or charcoal inside your radio, but will make you wonder, why can't I receive anything today after that lightning strike? So
Mhm,
enter the lightning arrestor.
mhm. We got
Notice we've skipped our. Sorry, go ahead. I'll take a
Steve.
drink.
Yes, you're fine. You're fine. Steve's joining us as my co-host today, so he can run the chat room and drop the links. I appreciate it, man.
What's up? Throw me a wrench, brother.
You don't have a wrench? What?
Nope.
You got to close and start the stream again. But
What?
done.
All right.
Boom. Also, sorry, my lighting is wonderful, by the way.
You're right.
I
You
was
know
going to
what?
bring my...
I could compliment you. There.
There we go.
I'm
Oh,
dark.
thank you.
As I turned mine
I was
on.
going to bring my... I was going to bring my Elgato thing, but I realized it was like... I did cable management really well, but like that means you have to uncable manage to get all of the things that you want. So
One of my
fortunately,
videos
this
will
camera...
be the studio lights, but my studio lights turn on and
Yeah.
off with a button underneath the table. So no hands. What?
Nice.
Beautiful.
Awesome. So we lightning arresters.
Yes.
So
What
they're
are they?
important.
How do they work?
Yes, yes, and yes.
And when do you use them?
Yes.
There are a variety of lightning arresters. The most popular ones are called gas discharge tubes. And essentially what that is you have, let me see if I can draw it kind of roughly on my iPad. You might have to like bear with me. This is my dry erase board.
Perfect. I love the imposition.
Yeah. Can barely even see it though. Let me use
There you
some
go.
thicker. I'll use a thicker. Yeah, like that. Okay. So imagine you have your coax line.
Yeah.
And then you have your shield. So it's like two parallel lines. So and then this is the center one is like the inner conductor. And let me space this out a little bit more just so I can draw in between them. What a gas discharge tube, gas discharge tube, GDT. These are your polyphasers, by the way. What that does, it acts like a little thing in between the two, the center conductor and the outer conductor, because ideally your outer conductor is going to ground where there is a path of least resistance. So this gas discharge tube, what do you imagine it does whenever that particular line
so
is
the
at
top
a
lines
really high voltage?
Our antenna line, right?
Yep, that's your radio.
That's where it's going to my radio. So for somehow
your rig.
The magic box tube, when it sees high voltage, somehow kicks on, and it allows the lightning to flow, hopefully to ground, because it's least resistant that direction to your radio.
Exactly. So the gas discharge tube contains a gas. You were right.
Where's the soundboard? Balloons drop. I did my research.
So that gas discharge tube, that dude right there, it contains a gas, like I mentioned. There's like, I don't know what gas, like xenon. Basically, there's a specific amount and a specific pressure and a specific type of gas that at a specific voltage and at a specific time, at a specific current, it will allow current to pass through that without passing into the rig. So at a very high voltage, say, I don't know, 10,000 volts, that gas becomes ionized. So an ionized gas is a gas that is able to basically transmit electric current, aka there are free ions moving in air in like a gas channel, where the electrons are free to be pulled away from the atom of that substrate, that xenon or whatever gas, and can move freely because it's at such a high voltage. The higher the voltage, the more likely it can kick off electrons from molecules or elements like oxygen and nitrogen in the air, and then freely move that channel. So that's what plasma is. Plasma is an ionized, state of matter where it's super high energy, and you get aurora and you get lightning. That's literally what lightning is. It's a plasma arc of ionized gas of the air that is just at a super high voltage that allows lightning to find the path of least resistance through what is normally a very, very good insulator, which is air. Like, I mean, that's why your batteries don't arc, like, with their contacts this far apart. That's why it takes like a Tesla coil or like one of those like static generators that you put your hands on and your hair, comes out on, end to make shocks happen. Or that's why it takes so high voltage to shock yourself on a doorknob, which It's the winter, so we all see that. So
Mm-hmm.
that's how that particular gas discharge, that particular lightning arrestor works. There are even more, and that I want to mention. So the polyphaser, ideally, like that's pretty much all you need. But there are others out there that are passive circuits, or they have metal oxide varistors, MOVs, which are very similar to operation, where they basically pass a high voltage current through so that it doesn't get into your rig. I think, what is it, the Alpha Delta or Alpha Engineering or ICE, the ICE. I think these things might all be available on DX Engineering or Ham Radio Outlet or whatever. But the ICE is a passive circuit that looks quite an awful lot like, you got like an inductor, maybe a capacitor, and then like a special type of capacitor that goes to ground, and some other circuits and whatnot inside a box, and that goes to your radio. So at some point, at some voltage, at some current, it allows that high voltage to flow. Let's go back to gas discharge tubes. So imagine what happens after that polyphaser protects your equipment. You get a local lightning strike, and then all of a sudden you don't hear like your radio, and then you unplug it, you plug it back in to a different coax, and your radio actually sounds fine. What's happening is that discharge tube has been used up,
Mm-hmm.
and it's allowing even more current to pass than its like initial, because it's in the protection mode, right? And there are some gas discharge tubes that are resettable, that automatically kind of come back in, and you can use them over a period of time. Like you use them over several discharges, but at some point you have to actually replace that gas tube, because that gas will either get ionized, or it will like be such a close strike that you can actually pop the tube and the seals will let the gas out, so then it won't be usable anymore. So you have to like check these things, and I think there are ways to do that, but probably won't get into detail here. But these ones don't have gas, don't have any replaceable items. They kind of act like they are always, protecting your equipment.
Mm-hmm.
But they can only go so far, because you're dealing with passive electronics, and those can be damaged, but they are designed with the intent of, a bajillion volts coming through them. Well, not quite a bajillion, maybe 10,000 volts or something, 5,000 volts or something.
What
So
site you recommend to look at a couple of these? I was trying to pull that you said radio engineering up, but I couldn't find it.
yeah, DX engineering. Well, so if you look up lightning protection or lightning protectors on the World Wide Web, you'll kind of find those two types. The polyphasers, POLYPHASER.
Mm-hmm.
Those are really popular. They have like their own website, and they look like here's one from Gigaparts. They look like that. Well,
Ooh, 10% off.
$10 off. They look like that.
Uh-huh.
And then this part like mounts to a ground flange or something. Make it bigger. Why don't you get bigger? So this also has another consequence of actually plugging this thing into say your ground, because you want to mount these to a ground.
Show that on the
so
screen real fast. Yeah. So we see where the antenna comes in and the antenna goes out. Then I see somewhere it bolts to where, and how does it connect to ground? So there's
that flange.
Yes.
Yeah, that flange connects to ground. That's where you put it to like a I don't know, a bus bar, or you mount it to a ground like panel of some sort, so that that energy can flow to ground. If you just if you just put this on your coax, it does nothing for you. Sadly, if you don't ground it, it will not be effective. So you have to ground these things so that the energy has somewhere to go, right? So, and then on some of the units, they actually have user replaceable ground things, but I don't see like where you can on that particular unit. I've had ones from MFJ that have like a little screw on top, and then you can put in a new gas tube. But you can also buy those gas tubes, which are connected to two leads, to individually protect, say, a bunch of rotator controllers, like wires, or stepper step IR controller wires or something like that.
Mm-hmm.
So that's also, and that's what Ward Silver does, N0AX. And if Kyle AA0Z is in the chat, probably harassing me on like, you're wrong.
Yeah.
I saw him earlier.
A thing or two.
So I
He knows
pulled
quite
up
a thing or two about
XD
grounding.
Engineering here.
Mm-hmm.
Do you have to match the antenna arrestor to the bands that you're going to be operating on? UHF, VHF, HF?
Nope.
No? It's just...
Yes, well, I guess to a degree. But generally, you can see like these will cover DC to 3000 megahertz.
Mm-hmm.
Because literally, you just have like a straight path of, it only depends on like the quality of the connectors and stuff.
Mm-hmm.
But it's just a straight path and then a T where the gas discharge tube touches.
Mm-hmm.
And then that connects to the chassis of the lightning arrestor. And so that's like naturally pretty open to like all frequencies, since you're just, there's no like there's nothing like RF wise. When you go to 3 gigahertz and on up, that's different because those are little tiny waves that can do wacky things inside of cavities.
Mm-hmm.
But for HF, for VHF, for UHF, almost every polyphaser or lightning arrestor like you're seeing here will cover DC to 3 gigahertz, so you're good there.
So this one is a diamond antenna SP series lightning arrestor. I'm going to read the description. You're going to get me reading off the cuff, so I'm sorry. Coaxial lightning arrestor SP series DC pass, DC to 3000 megahertz, 400 watts. PEP, RF power, N-type connector, and another type connector. Cool.
Mm-hmm.
So,
and you can see at the top of there, that little like knob on the top, that's actually where you can put a new discharge tube.
Mm-hmm. Oh, so if it's been used, or like you said, you clicked it over and you can't get anything out of it, then you just pull that tube and replace it with a replacement.
Yeah.
And can we tell if this was polyphase or what was the other type?
That one's a diamond. That one's a diamond, and then you have alpha, delta, and polyphaser, or the other main ones.
Those are brands. I thought
those are brands. Yep.
You're a little hot there, Steve.
Oh, sorry. Let me turn it down.
Any questions from the chat so far? Because I stopped reading it as soon as you came on.
Nothing that I've seen. Nothing that I've seen.
Yep. So go ahead, if you have a question, go ahead and throw it in the chat, and Steve will work them in there as the conversation evolves, or we'll hold them to the end and run them through lightning style with no pun intended.
Oh, pun totally intended on that one.
So that seems pretty easy. So the idea I have here is I need a lightning arrestor for every antenna I am going to run into the house.
Yes.
Does it matter where on the line it is? Do I run it next to the ground rod at the base of the antenna?
Yes.
Do I run the whole feed line to the house and then have a junction box where they're all connected to the ground?
I think there's a couple of schools of thought. I think the ideal one is you actually use more than one. Like you would have one at the top where the antenna meets the tower, and the tower is grounded, but you'd also have one at the bottom, like where your ground system is. But most of us won't put one at the top because that's silly, and I don't even think commercially that's a thing that's done. I've heard it happen though. But no, you put it on, like your antenna's up in the air, and then your feed line comes from plug in directly to the antenna, and your feed line comes all the way down to the ground. And then you put your polyphaser where your ground system is and where it will allow you to connect that polyphaser or lightning arrestor. A lot of us use polyphaser as like, basically it's like the Kleenex of lightning arrestors, or the iPod of MP3 player, you know. So, but the one really, really important aspect about grounding is that you want to keep any sort of connections as low impedance as possible. So very fat connectors, very wide, or just like literally bolt the polyphaser directly to your ground rod or to like a ground panel that is like very close to your ground system, your ground rod, and all of that. So, and then that also goes into the whole thing of like how the ground rod, what kind of ground rods you need, and your perimeter ground and all that important stuff, which you've probably seen, or if you know N0AX or seen any of his grounding and bonding presentations, or even Tim Duffy, then you kind of know where we're going. It can get pretty expensive because you want a perimeter ground, but you don't really need a perimeter ground. You can get away with like maybe 2 or 3 ground rods spaced up wherever you can. But typically perimeter grounds are so that you can basically tie into your ground at any point around your house wherever you need. But if you don't need to, say, tie it to your ground on one side of the house where you have nothing, and then but all of your things are on the other side of the house, then that's fine. You can put all of your ground rods over on that one side, but you probably want more than one, and you want to bond those together with like very thick 4 gauge or 0 gauge or copper strap that's under the ground, so that it's super, like, it's basically giving Mr. Lightning the best chance to find his path of least resistance, because they need to go to the ground.
We had the grounded discussion a couple weeks ago with RF Field Tech, and I went ahead and linked that link in the description, or not the description. We could go ahead and throw it in the description, but into the chat. That is a good video to go ahead and watch for grounding. So I am going to have a grounding rod at the base of the antenna.
Perfect.
And it's going to be, I don't know, 10 feet to the next ground rod at the base of the house. So my original plan was I was just going to run that all the way down around the fence line through a conduit underneath my yard out there, up to the house and into a junction box. And that junction box was going to have the lightning arrestor, a copper plate for all the lightning arrestors to attach to the lightning wire coming out of that box straight to the ground and working its way around the house to be eventually, we're going to skip that part, but it's going to connect to the house ground way on the other side of the house, because my chimney's there where I want the antenna and everything coming in. And over there is where, over there is where the all the power comes into the house. Great planning, Frank. Choose the worst place to put your antennas.
Yep, and you know it's the worst place because you got to bond those ground rods together. Like, you cannot have a situation, and if you do, it really impacts your ability for Mr. Lightning to find his way into your stuff. Because if you have more than one ground system, essentially what you're hoping is that the ground, the actual earth, can support that current and that voltage, that electron flow, for when there's a lightning strike. But what is going to actually happen is that the ground is actually a bad conductor compared to really thick copper. Is what you're going to have happen is one of your ground system is going to have higher voltage, and then the other one is going to lag that as the wave propagates, if you will, and that is bad. Everything bad in grounding is if you have a difference in potential of ground systems, and that's what causes damage. So even if you have no ground and you have one radio at 200 volts and the other radio at 0 volts, then you have a 200 volt difference between the two, and that's enough on a tiny little circuit board trace to cause an arc into, fry a microelectronic. That's why you ground everything, right?
That's what we're trying to impede.
Let the magic smoke out.
Resist.
Yep. So, exactly. So, hurry up and get that copper wire so you can get that other ground rod bonded. That's for sure. And then you probably also want to get a few more ground rods and put them in like every, I don't know what the code is. I'm sure there's a code, but it's like every 32 or 16 or 8 feet, I'm sure. Something like that.
It's more than the length of the ground rod. So if the ground rods are 8 foot, you have to go at least 8 foot. I suggest 9 or 10.
I'm feeling somewhere between 15 and 10. It's just how they kind of randomly, or not randomly, but how they're going to easily drop within that range.
Yep. I went 12 foot on mine, and I have the same problem. My electric comes in all the way over there, and my wires come in right there underneath that window.
So, quick question. When people say bonding, that's when you just connect the two ground rods together.
Yes.
It's not like I'm tack welding and bonding them.
Well, you could CAD weld them.
Oh, yeah.
So CAD weld is a one shot, literally like a thermite crucible that you put over your ground rod to like literally connect through metal. Melting the metal.
I could play with explosives.
Yeah. I mean, that's how they do
technically.
train. They weld train rails together.
I'm
They
totally
actually
gonna do
weld them
this.
together with thermite.
I'm totally going to do this. I got to find someone to do this for me.
Until you see the price of those.
I'm going to invite
Yeah.
our field tech to do it for me. And I just want
Do
to
you
push the
do
button.
you can definitely DIY if you want to make your own thermite. But then you got to be like, well, did I actually
Dude,
make
don't-
that? Because CAD weld is specifically made so that you get a really good connection.
You
But
don't
if
want
you
to
do it yourself,
tell
you're
Tank Radio that. Don't tell Tank
Yeah.
Radio that. He will actually do
No.
it.
No, you need to buy the actual one shots or the CAD weld, and it's real easy to do. Yeah, it comes with the striker, so.
Cool. So moving on, that's great information. So we figured out what I need to do for lightning arresters now, and the next part of the question is for you: is can you talk to me about Feedlines? I know
Sure can.
I know I need good high quality feed lines. I know, when they talk about the braid and how much they're shielded and all that stuff, but why do I need a more shielding, less shielding, thicker feed line, smaller feed line?
All right.
What
Yep.
Because
What's the deal with feed lines?
I know enough to pass that
What's
test.
the deal with airport feed lines?
We are not going to talk about airports because I get pulled by the TSA every time. I don't understand why. Jason always is on the other side watching me. I don't want to spend the money on it. But that's a discussion on another time. Another time.
$70 for 5 years. It's also dumb because it's like, yeah, I'm paying you to let me go in private. It's kind of stupid, but
well, my feeling is you're perpetuating a broken system.
So much time.
So
yes, exactly.
But
it saved me like
there is my 2 cents or 2 coins.
Kaboom.
Kaboom.
Now I got global entry, which is like even better, but
ooh.
I digress. So feed lines. Remember what I drew earlier? That's 1 wire and that's 2 wires. So there's a feed line. Boom, done. That goes to your radio, that goes to the ground. Or does it? Who knows? But essentially what a feed line is 2 parallel conductors must be parallel that feed energy to a device, a thing, from a generator of said energy. So what we have here is a whole bunch of variables that are into play. So like you have the spacing, you have like, say if there's like metal, there's a proximity effect, you have like frequency differences, and you have the length of the line, you have, just a whole number of things. And this is just 2 wires. So like a balance line or window line or ladder line. That's what we're talking about here. That's the most basic feed line.
Guys, guess what? The channel...
So those have their benefits, but they also have their downbacks. Their main downside is that if you put a balanced feed line in the proximity of metal, so like a gutter or even a wall, something conductive, it can mess things up a little bit in terms of SWR because they have quite a big field around them. They actually will radiate, not really radiate, but they'll have a magnetic field around them a little bit so that if you get close to them, you can mess that field up and mess the specific capacitance and inductance of that particular feed line so that it changes its impedance. Okay, so all of these big words meaning you mess it up if you get it close to metal. So, but their benefit is great. If you need a really long feed line, balance line and window line have very low loss over that course of line. So say if you are in a broadcast station and your antenna is 2 miles that way, you can run balanced line over a long distance and not have that much loss compared to coaxial cable. It's also cheaper. It's also, if you can stand it off about 12 inches or more from metal, it's good to have. For certain, it's also really good for certain antenna designs like doublets, where it's literally just a dipole that's connected to balanced feeder that goes straight into the rig. Or a tuner. That would be an antenna tuner. So you don't have to finagle with coax cables or connectors or whatever. It's just solder. And even you're looking at it here like an off-center fed. That works really great because an off-center fed has an impedance of 200 ohms, and typical balanced feeder is 300 ohms. That's actually really close good enough, and it works multi-banded. So that's that feed line. Then you also have, everyone knows about coaxial cable, and that looks like you got a shield and then an inner conductor, right? So exactly same thing that we had before in an electrical sense, but there is a continuous shield around that inner conductor with like an insulator in between it, so that when you put energy into it, it won't arc, it won't short circuit, like we talked about lightning earlier. So now there's all these other variables. You have still the same kind of thing: capacitance, you have inductance, you have length, you have the diameter of the coax versus like the diameter of the interconductor. You have just a whole number of differences and things and changes. And then the outer conductor, say if it's not a continuous like copper pipe, you would have a braid, and that has a certain percentage of coverage. Some of them will have foil. Some of them will have like 5 layers of foil, or a layer of foil and a braid and another foil and another dielectric and another braid. And then all of this is in the name of trying to keep the losses at a minimum. So coaxial cable is high loss cable. And this is because, and I'm trying to like think on my feet. This is basically because, let me clear this up a little bit. Trying to remember exactly. As compared to a balanced feeder, which is basically sending a propagated wave over like a very good conductor, this is setting up like skin effect. And how does sorry, I come here a little unprepared because I forget exactly why coax cable has higher loss. But I think it has to do with the lumped element model. Like it's essentially like a whole bunch of capacitors and inductors, and it's this whole chain. And because you would think like if you completely shield like the inside, you do this one great thing where, remember how balance line is very susceptible to getting messed with by metal and stuff. Coax cable has no external field whatsoever because it's entirely, all of the energy is contained within that braid.
So you're talking about you're hinting right here about the right-hand rule with current flowing through a wire, and the electric magnetic field that runs around with it as current flows.
Yep.
So the coax cable, depending on the braid, will eliminate that, and because it's eliminated, it also will not be interfered with, or depending on how much you shield, it can limit that, and it will limit the interference.
Yeah, exactly. I mean, so Faraday's
only took
first
3
law,
tries to finish
physics. Sorry, this is an eyeball. We can look at this as an eyeball, right?
Straight on.
Let's not be, get our heads out of the gutter.
I wasn't thinking that.
So basically, you go back to Faraday's like Maxwell's equations. Have you seen the grad del of B equals 0? Yeah, I know, right? Big words.
Yes.
Or the grad del, the del of grad, the grad of D, the grad of B equals 0, or something like that. Basically, that says inside a closed container, like nothing can get out except for a magnetic field. But since you have a current going this way on the inner and a current going that way on the outer, on the inside of a coaxial cable, then that sets up a system of electromagnetics inside the cable where there is nothing on the outside. So like whatever you do, you can put it in conduit, you can hold it, you won't feel anything, it won't mess with anything except for when you have common mode currents, but that's a whole nother thing, right? So that's a coaxial cable, and they're higher loss than balance line. They are more expensive, obviously, because you have like a thick copper and then a shield and then dielectric and then a jacket on that dielectric that goes around it to protect the shield from, so you can bury it or put it, keep the squirrels out from gnawing on the nice copper metal. So what you have to do here is trade off. Like you have to do trade-offs, you have to compromise, you have to think, okay, how far away is my antenna from my radio, and how much loss am I willing to tolerate to get my signal to that antenna? Because every coaxial cable, every feed line comes with a loss per length which is dB per 100 feet or dB per 100 meters or dB per foot, where you have, say, if a cable is 3 dB per 100 feet and you have 100 feet of cable, that's 3 dB of loss at that particular frequency, because it depends on if it's 30 megahertz or 300 megahertz, right? But for that particular frequency, if you have 3 dB over 100 feet, that's half of your power being lost to making the cable a little bit warmer, right? So you don't want that, but you have to compromise if you want to use coaxial cable, which you probably do. So they make a whole variety of cables, which go from super tiny, like, little tiny guy, all the way up to like heliax, which is like corrugated copper pipe with a center conductor. It's literally like what you see on cell phone towers. With like the 2-inch or the 1-inch pipe that goes up to a cell phone. Nowadays, like, they have the radios actually up on the thing, but back in my day.
So that's the kind of the differences they're talking about. LMR 240 versus 600 versus
Yep. I forget what those mean, like the 240, 400. I think those are diameters of the outer jacket. But basically, LMR 200 has higher loss than 400, has higher loss than 600, so on and so forth, because one of the easiest ways to improve the loss is to make the cable wider. So, like, if you go from this to a larger one, the smaller one's going to have higher loss for some reason. I forget. Than the larger one because of magic, but also lower quality cable that has like only a percentage, like a less than 100% coverage, will be leaky to a point where it is also higher loss. So RG58 is a perfect example, but compare that to RG8, RG8X, which are typically 100% coverage. Those are better cables to pick from than RG58.
So
everyone should never use 58. Everyone should pick.
I'm showing on the screen here, like you were saying, RG8 has a diameter of a 0.194 inch. As standard usage is for mobile installation. Then RG8 has a diameter of 0.242. Sorry, I'm dyslexic and reading numbers take me a minute to get in the groove. As it says, it's a larger diameter, and then it can be 50 ohms up to 50 feet. So no really longer runs than 50 feet. And then still in the RG scale, the RG-U8 is 0.405. General purpose coax cable, best for long runs. On this series of cables, I think I would, and now I got a picture up showing the inner cable for the antenna. The dielectric shielding the antenna from the woven braid, and then the copper or the plastic jacket there. I guess I need on the RG scale. Is RG and LMR different companies, and that's why they're named differently?
Okay. Yeah, they're different companies, and the LMR actually is the outer diameter.
Okay.
Yeah, if you go by times microwave. So.
Yep.
So LMR 600 is 0.59. So yeah.
LMR is Times Microwave Systems cable. That's a brand. So LMR 400, that's a brand. But DX Engineering actually sells their own DXE 400, which is like a carbon copy of LMR 400. And I think Davis RF also sells like a Davis RF 400. So a lot of the competitors out there sell very similarly spec'd cable because they're standardized, because those cables have to fit into a connector, and you don't want too many different cable diameters that you have to have a bunch of different adapters for one type of connector, or a bunch of different connectors for each individual type of cable. So that's why they say the standard PL259 is specified for LMR 400, for RG213, I think, for anything that's about 400 millimeters, right? Steve. Or something like that. Not 400 millimeters. 400 millimeters. I forget.
Yeah. So if you go by millimeter, LMR 400 is 10 millimeters. So.
Yeah. So freedom units. Stick
Freedom
with the
units.
Freedom unit.
Yep.
Woo!
Yep.
I like freedom units.
So the veritable PL259 that screws on and then you solder the holes, those are designed for RG213. And it also works on the 400, but you need a reducer for that to work it with RG8X or RG58.
So for my
And those are
longer,
actually two different reducers.
so I'm gonna have it come into the middle of my house, and I haven't measured yet. It's probably about 30 feet plus dropping down the wall another 8. I could probably get away with a lesser thick line.
Yeah, but what frequency?
RF. So I'm
2
gonna.
meters? Or...
Does it matter? That's a good point. Does the
Yes.
frequency matter?
Yes.
Absolutely.
Big time.
So I'm gonna have one UHF VHF antenna. I'm thinking about a 111 meter antenna because if I can get a CB radio, that would be fun to have in the shack. Why not put it on top of the house? And then I'm
I
going
would
to
do
have
that too.
3 HF antennas. Run them all now. Get the lines up so I never have to mess with it and monkey with it again. So I'd rather have extra lines. So does it matter if I run a UHF VHF antenna on all of them? I just buy 2 300-foot spool and just cut and put the ends on as I need, or should I get a different one for the VHF spectrum versus an HF?
You probably want to go with a different cable for VHF, UHF, especially UHF, if you want to get any kind of signal to your, depending on the length. That's what really matters. Is like, how much loss are you willing to, handle? So say you have like a big old like 12 dB or maybe call it 6 dB like vertical on 2 meters, and then you have like 100 feet of RG8X, which is probably gonna put in the range of like, I don't know, 5 dB of loss, 60, let's call it 60 dB to be even. That's 2 times 2, 4 times the amount of power. Four times 4, a part of 4 of your power is being lost to that to the cable. So are you okay with that? Are you basically okay with turning that 6 dB antenna into a 0 dB antenna, which is no better than, say, a ground plane or a Slim Jim? Or do you want to either shorten that cable, like move your radio closer to the antenna, or get a thicker cable like 400 or 600? If you're crazy like me, I'm trying to spec out this exactly for my house. And, have a little bit lower loss so that you have more range, essentially.
Yep.
So there's a question. How long?
I'm looking at Times Microwave right now, and LMR 400 at 100 feet, 450 megahertz, you're at 2.7 dB loss.
Yep. I got it right here.
Yep. We're looking at the same page.
There's your curve. So on the bottom
Frank,
of the
you're muted.
I was sneezing.
Okay.
I was sparing y'all. I was taking a 400-foot length and I was going to cut it to sections. So I wasn't going to run the whole antenna under 400 feet. I was just going to cut 30, 40 feet as I need and put end connectors and cut the next run and end connectors. And that's what I was going to do.
Yeah. Yeah.
So say,
if you did LMR 400, that would cover everything. It's just a matter of what do you want to spend. So
I like buying one spool and just cutting it to length.
Yeah, LMR 400 is pretty expensive, but there are knockoffs that are actually pretty good. DX Engineering, Davis RF, like I mentioned. But you also have to consider, say, if you're running a dipole and you run LMR 400, that cable is actually pretty heavy, and if you want to keep that, if you want to mount that dipole where you're putting tension on the endpoints and using the tension to hold the cable up, then you're gonna have to put a whole bunch of tension if you have like 50, 80, 30 feet of cable running from the ground up or from the roof up or whatever. So that would be better off if you're talking HF, RG8X. I'm really personally cool with up to 100 feet of RG8X. Basically, I budget 3 dB for cable loss. Like that's my maximum before I'm like, I want to get better than that and that's if you're going really far.
Well, right? I'm going to have to stem the conversation here. This has been a great talk. Jason's about to come up. So Sterling.
No.
I am going to do is we're going to have you back on And what I'm gonna probably in about another month, we're gonna talk about final shack design, and you can come in
Ooh.
and teach or not teach because you pretty much gave me all the information I need. I hope y'all too.
Oh,
Mhm.
no
On
worries.
what I need to go out and buy, and then you can. And I'm going to present my whole design, and I'm going to have a couple guests on, and you're going to tear it up, and we're going to get it right, and then I'm going to start buying things. How's that?
You and me both. You and me both, because I don't have a HF station in my house, and I
Mhm.
really want one, or a station at all. I just have portable operations. So,
We're same boat. So I'm going to go
yep.
ahead and get the floor to you, Sterling. Go ahead and tell me what's going on in your life, your stream, anything you want to promote. You full
All
screen.
right.
It's all you.
All right. So, Sterling, N0SSC, thank you for watching and listening to me blabble on again. I love this kind of stuff. I have a really defunct YouTube channel. You can go watch it, N0SSC. Just look it up. But I really want to promote Youth on the Air. Go check out youthontheair.org. We have a yearly camp for young hams age 15 to 26. So if you know a young ham that age who wants to go to a camp for a week with their new best friends to learn more about ham radio than they ever thought possible and to do actual things and real activities, go check it out, youthontheair.org, and send me an email at sterling at
Awesome.
n0ssc.com if you have any questions, and I'd love to answer. So there you go.
Thank you.
Thank you.
Steve, you are full screen. What's going on in your world
Oh.
and anything you want to promote?
So I am trying to get some videos edited from Hamcation, as well as a little trip I took before up to Connecticut, and get that kind of stuff done. Tuesday nights, Ham Radio Clubhouse, 8 o'clock Eastern. You know, the only time zone that really matters.
No, Central. That's why
I know.
all of our calendars are Central.
Right. I know. Got to give you a hard time. But yeah, Tuesday nights on the Clubhouse. And then as I can get stuff going, you know, get my channel rolling up. So, and I am working on my getting an antenna up and perimeter ground and all that good stuff as well. So
Awesome.
I'll have videos on that coming.
Right on.
Sweet. And it's my turn.
Can't wait them.
I'm Tank Radio. You're on my channel already. Thank you for swinging by. I have everything on. I have podcasts. My podcasts, all my live stream podcasts are on almost every podcast app out there. Go ahead and search Tank Radio, because why would I name it anything else? I already have Tank Radio already mine. That's me, Tank Radio. I got the coins up. I have other merch on Jason's website. Jason's about to go ahead and give away, I guess, more antennas. What is this guy doing? I lost the stream. I closed the window by accident, but I am about to head over there. We're going to go ahead and figure out what's going on over there. But thank you for swinging by. Thank you for subscribing. Thank you if you're a Patreon. Go ahead and head over to my Patreon and subscribe. You get awesome end credits and other things. We had a Patreon meeting today. Thank you for everyone who showed up. And till next time, y'all, go forth and conquer.
73s.
Bye-bye.
Supporters, you can support me on Patreon. There is a link in the description below. And to all my tankers out there, go forth and conquer.